This is lesson 4, Wednesday, 2/10. Take a look at the homework from last night first, leading into, again, covering the same topic, only instead of words with symbols. So let's take a look at that homework first. We're taking the square root of x plus 3, and we're going to do a vertical stretch by 2. So that means taking this and vertical stretch by 2 means the entire thing gets stretched by 2. So I have 2 square roots of x plus 6. And then we're going to move it up 2. That's also outside. So the whole thing plus 2. The only thing I can do to simplify that is combining like terms. I get 2 square roots of x plus 8. 42. I start with 2 cubed roots of x minus 1. A reflection in the y-axis. That's a negative x inside. So we are going to replace x with a negative x. And there's really nothing to do to simplify that. And then we're going to move it 1 unit right. So I'm going to take this that I currently have. I'm going to take the x out, and I'm going to put in its place 1 unit to the right is x minus 1 in parentheses. I do have some distributing and simplifying to do here. I'm going to take negative x, and I'm distributing that negative. So that becomes plus 1, and then minus 1. Those two will cancel. So I get negative x on the inside. And I can take the cubed root of negative. It'd be okay if you left it this way, but if you take the cubed root of a negative 1, it's negative. So this would actually be the fully simplified answer. But if you left it back here, that would probably wouldn't take points off for that. Let's go to 43. I'm taking the square root of 6x, and I'm going to do a horizontal shrink by 2/3. Remember, we used the reciprocal. So that by 2/3 actually means 3/2 x. So I'm going to replace x with 3/2 x. It's going to give me the square root of 9x. 6 times 3/2 is 9. I can actually simplify that because the square root of 9 is 3. So what I have is 3 square roots of x. And then I'm going to move it left 4 units. And by simplifying it, left 4 becomes really easy because I just replace this x with x plus 4, and there's nothing left to simplify. Whereas if you would have done it back here, you would have had a 9 to distribute and all kinds of stuff. This is the most simplified. Let's get rid of this and take a look at 44. Starts us with something definitely more complex. But regardless, still following the same strategies. I'm going to move down 1 unit. So when I minus this whole thing minus 1, the only thing I can combine are these like terms. So negative 1/2, 4th roots of x, plus 1/2. I'm going to move right 5. That means replace x with x minus 5. That's going to move it right 5. And there's nothing else inside, so nothing to simplify. And then I'm going to reflect the x-axis. That means the entire thing, x-axis, that's a negative on the outside. So the entire thing gets multiplied by negative 1, making positive 1/2, 4th roots of x minus 5, minus 1/2. Make sure you change both signs, here and here. And that's the simplified answer. Now we're going to do the same thing, only we're going to do it with symbols. And we're going to do some context application problems. This function that they're calling e is 0.25 times the square root of d. That tells you the number of seconds it takes for a dropped object to fall on Earth. So you drop an object, how long does it take for it to fall? On Mars, gravity is different. So whatever Earth's equation is, Mars is 1.6 times greater. Or in other words, a vertical stretch of 1.6. And this equation is telling you what to do. Take E and vertically stretch it by 1.6, or in other words, multiply it by 1.6. And you can see here it's exactly what they do. What I'm trying to find is the Mars is 1.6 times Earth's. So if I take the Earth equation and stretch it by 1.6, so this stretched or multiplied basically by 1.6. That's what they're doing. Take the Earth and stretch it or multiply it by 1.6. 1.6 times 0.25 is 0.4 square roots of d. Now they also ask you to determine how long it takes for a dropped object to fall 64 feet on Mars. M of 64 means take the Mars equation, which is this new one we have here, and put 64 in. So I would just put 64 in for D, evaluate that. 3.2 is how long it would take on Mars. Which, how long would that take on Earth? 0.25 times the square root of 64. That's 8 times 0.25, a fourth of 8, is 2. And if you took 2 times 1.6, because we stretched it by 1.6, it would give you that 3.2. So that connection works. Now that's obviously a very simple transformation, to take something and just multiply it by 1.6, vertically stretch it by 1.6. Okay, but that's where transformations are used. Something as simple as this, taking something that exists here and it's being stretched in this case because Mars has a different gravity. So we're going to do that very thing, and this is for in-class work. So what I want you to do is to try 47, pause it, try 47, and then unpause, and then see me do it. And then do that for 48, 49, 50, and on the next page, which is the application problems. So now that you've tried it, we're going to take this and we're going to do f of x plus 3. This is a substitution. It's inside. I'm going to use the same strategy as yesterday. Inside uses substitution. So I'm going to take 2x, I'm going to take x out and put x plus 3 in its place. Final answer, that's g of x. That's it. Let's try 48 now. Pause it, unpause it when you're done trying it. Okay, so let's take a look at this. What I'm starting with is 1/3 square roots of x minus 1. And what they want you to do is take f of x, which is what this is, f of x, and I'm going to multiply it by -1 on the outside. So this is an outside number. So take this and multiply the outside by -1. Now there's no k value, so there's nothing to multiply out there. So it's literally just a negative in front of that expression. And then add 9. Well, again, there's nothing out there. So all I'm doing is tacking on a negative in front and then adding 9 at the end. And there's nothing to simplify. Okay, super easy. Got a little bit more going on here. Let's take a look at 49. And they threw us a curveball with f of x by making the x inside be squared. But still, it's not something that we can't handle. And so we're going to start. Now we have to follow order of operations. We're going to go back to that hack because it doesn't tell you what order. The words yesterday told you the order. We don't have that here. So we're going to follow hack. So go ahead and pause it. See if you can do the parentheses first and then this. Okay, so let's take a look at 49. So I'm going to start with f of x plus 5. So we start with what's inside first. So x plus 5 takes the place. This is substitution. So I'm going to take this, I'm going to take x out, and I'm going to put x plus 5 in its place. Substitution. This comes out, that goes in its place. Okay, and we may clean that up here in a second, but we're going to go ahead and do the other transformation, which says take that I just did, and it also is telling us to multiply the function times -2. So multiply the whole function by -2. It's going to make a positive 2 times the square root of x plus 5 squared minus 2. Now let's clean it up. So what I have is 2 square root of, we know how to square a quantity, we've done it a lot, x squared, don't kill the puppy, plus 10x, make sure that 10x is in there, plus 25, when I take this times itself, minus 2 would give me 2 square roots of x squared plus 10x plus 23. Final answer. I'll go ahead and try 50 and then pause it, try it, and then come back. Okay, so let's go ahead and take a look at 50. And on 50, I have the cubed root of x squared plus 10x. Now I have two x's here. It gets a little dicier. Starting inside, I have a negative x, which is a horizontal reflection around the y-axis. But this means that I'm going to replace x with negative x. So I'm going to take x's out and put negative x in its place. And I need to do that for both of these. Okay, we'll clean that up in a minute. And then it tells me to multiply the function f by 1/4. So that means a 1/4 goes out in front, multiplying by 1/4. Then it tells you to add 6. And again, because there's nothing else with it to add and subtract, it's just plus 6 in the end. If there was something else, then I would add or subtract it. Combine like terms. If there was another term here, let's say that 6 was already there, then I multiplied by 1/4, I would have to multiply this by 1/4. Okay, but if you follow order of operations, that plus 6 comes last. I do have to clean this up. I have the cubed root of negative x squared, and negative squared is positive. 10 times negative x is minus 10x, and then plus 6, and that's the final answer. Okay. So again, it's basically the same as yesterday. We're just doing it with symbols. Make sure what we do inside, we use substitution. Anything outside, we apply it to the whole thing. Okay. So again, if I would have like the square root of negative square root of x plus 2 plus 8, and I was told to do negative f of x, that means multiply f of x by a negative. I would have to change both signs and apply it to both things, just like we talked about yesterday. Okay, let's try this. Let's wrap this up. Take a look at 39. Pause it. Try it. Come back. Okay, so what we have here is the distance a pilot can see the horizon. Now on Earth, that's 1.22 times the square root of n. How far it is to the horizon that they can see, a pilot can see up in the air. Okay, and you can see them looking at the horizon. Now, because the Mars is a different shape, and because Mars is a different shape, that it's a smaller planet, we're going to take Earth, and it's going to be 0.75 or 3/4 of that. So we're actually going to shrink this function. So I'm going to take 1.22 times the square root of n, and I want to take what Earth is, and I'm going to multiply that by 0.75. So a vertical shrink of 0.75. So when we multiply those two together, I get jumped on me there, 915 square roots of n. That's the formula for Mars, pilot being able to see. And then it says, what is the distance a pilot can see in the horizon from an altitude of 10,000 feet if they're on Mars? So then I would just plug 10,000 in here. Square root of 10,000 is 100. Multiply that by 0.915, and I get 91.5, which is how far that they would be able to see. Alright, so take a look at 40, and on 40, go ahead and pause it, read it, give it a try. And on 40, they're taking the speed, sound waves in the air, modeled by this function, and they're doing it in Kelvin. And what they want to do, the speed of sound waves in the air can be modeled by s, is the velocity. So this is the velocity, how fast it can go, and we're going to just divide that by 1.944. So taking this function, 643.855 square roots of k over 273.15, and we just divide it, which means I can't divide what's in the square root, so I'm dividing what's out here by 1.944. So just divide these two numbers, and what happens inside doesn't get touched. And that's it. We're done.